Okay, sixth graders, we're going to go ahead and look at function tables on page 579. So get your book open at 579. Again, hit pause at any time during this video if there's something you are not understanding, and ask for clarification from the teacher that is here or myself if I am here. And let's go ahead and get started. So let's take a look at this real world link. It says a ruby-throated hummingbird beats its wings about 52 beats per second. Make a table showing how many times this bird beats its wings in 2 seconds. So in 1 second, we know it beats 52 beats per second. So if we wanted to figure out how many it did in 2 seconds, right here, we're going to take that number, 2 times 52, because in 1 second it beats 52, which is going to give us 104 wing beats. Okay, that's like how fast a hummingbird moves. Okay, if you've ever seen a hummingbird, they go really fast. So now let's take a look at number 2. It says make a table to show how many times it does it in 6 seconds. So we're going to take 6, and you should be doing this with me, times 52. And 6 times 52 is 312. Okay, notice that I am following this rule that is right there. All right, let's take a look at number 3. It says make a table to show how many times it beats its wings in 20 seconds. So where it says number of seconds, we're going to do 20 seconds. And so we're going to take those seconds times 52, which is going to give us 1,040 wing beats per for every 20 seconds. That's a lot. Okay, let's take a look at the next one. It says a giant hummingbird beats its wings about 10 times per second. Make a table to show how many times a giant hummingbird beats its wings in 3 seconds. So we want it to be 3 seconds, and we're going to take those 3 seconds times 10 to give us a total of 30 wing beats. Okay, this is an introduction to what we're doing. So go ahead and turn to the next page. And there's a whole bunch of vocabulary up here, and we're going to talk about those really briefly. All right, a function. Okay, here's what it really means. A function is a relation that assigns exactly one output value to one input. We are going to be seeing things that you're going to want to know, which is the output value and the input value. All right, so for example, the number of wing beats was the output, depends on the number of seconds, which was the input. The function rule describes the relationship between each input and output. So, for example, when we are multiplying by 52, that's because in 1 second that hummingbird wing beats 52 times. Okay, so when we wanted to find how many it did it in 2 seconds, we multiplied 52 times 2. So that was our rule. It was our second times 52. All right, and we can organize this in a table, which is what you see right down here. That's a table. Okay, so if we're going to talk about the independent and dependent variables, the independent variable is also known as the input. Okay, it's where we've started, and you'll see that down here as well in the function table. The dependent variable is the output, okay, the number that you get. All right, so let's take a look at some of these examples. It says the output is 7 more than the input. Complete the function table for this relation. So I'm going to make this a little bit bigger, and we're going to take a look at this. So my input, notice that my input has this x next to it. Here's my function rule right here. We're doing x plus 7. So I'm going to take my input, my x, plus my 7 to get my output, which is 17. Okay? I then am going to take my x, again, I'm going to go down to 12. My x is 12 plus 7 to get 19. And then notice this x is 14, so 14 plus 7 is 21. So all I am doing is I am replacing the x in this function rule, okay, with the x that's in my input. Let's take a look at what this looks like down below. Okay, the output is 5 times the input. Complete the function table. So the rule is multiply each by 5. So here, I'm going to come over to this graph, this function table, and I'm going to replace my x with 8. So, because I'm taking 5 times 8, so 5 times 8 is 40. And then I'm going to replace my x again, 5 times this number, 10, which is 50. And then I'm going to take this number and replace it with my x, which makes it 5 times 12, which is 60. Okay, so basically we're just following the rules. All right, let's take a look at these examples together. So we're going to replace our x, just start with the first one. We're going to replace our x with 4, and then minus 4, because my rule is minus 4. So my rule is minus 4 or subtract 4. Okay, and 4 minus 4 is 0. And then I'm going to take the next number, which is 7, replace it with my x. 7 minus 4, which is 3. I'm going to take the next input, which is 10, and I'm going to do 10 minus 4, which is 7. You should be doing all of this with me. So if I were to come back to your book, this is going to be filled out. Okay, let's go ahead and do B. Notice we're multiplying by 3. So here I'm going to set it up. 3 times 0 is 0. 3 times 2 is 6. And then 3 times 5 is 15. Okay? Now, sometimes we're going to have to work backwards where they're going to give us the output. These are my favorite. This is where most of the math happens, which is awesome, which is what I love to do. So we're going to sometimes have to work backwards. So how does that work in order for us to figure out that, look, we don't have an input, so how am I going to solve this? But notice what I do have. I have my output. So here's how that works. I'm going to come up here, up to the top, for number 3. And I know that it is 3x. That's my problem. Do I already have an output? Yeah, I already have an answer. Okay, my answer is what? 6. So what I need to do is I need to work backwards to try to solve it. So I'm going to solve this just like an algebraic equation. I'm going to divide each of these sides by 3 to get my x by itself, which means that x equals 2. Okay, because 3x over 3 cancels out, and 6 divided by 3 is 2. Therefore, my input here is 2, which really means 3 times 2 equals 6. Do you see how I can do that? All right, let's do the next one. The next one is 3x equals 15. Okay, so knowing what we know, I want to get the variable by itself, just like in any other algebraic equations. So this cancels out, and I'm left with x equals 15 divided by 3 is 5. So I know that my input is 5, and 3 times 5 does equal 15. So I know I'm doing it right. And then let's do this last one. So 3x equals 21. I want to get the x by itself. The opposite operation of multiplication is division. So I'm going to divide each side by 3. This leaves me with x on this side. 21 divided by 3 is 7. So I put 7, and I get 3 times 7 is 21. So we basically just work backwards. That's it. That's all we're doing. So let's take a look at C. I'm going to kind of move over here so I have some room to work. Switch colors because I like to switch colors. Okay, so let's do C together. So again, we don't know this. We do know what our operation is, but we have our output, but we do not have our input. So we're going to go ahead and rewrite this problem knowing that we actually have our answer, which is 1. But we're going to have to solve this problem. So the first thing I want to do is I want to get rid of that subtraction. So I'm going to add 1 to both sides, which leaves me with 2x equals 2. And I'm not done yet because I now have to divide each one by 2. So when I divide each one by 2, this side I'm left with just x, and this side 2 divided by 2 is 1. So we believe that our input is 1. Now we have to check it. We want to make sure 2 times 1 minus 1. So 2 times 1 is 2. 2 minus 1 is 1. Check. Okay. Let's do another one. Let's do, so our output is 3, so we're going to rewrite this. 2x, oops, that doesn't look very good. 2x minus 1 equals 3. Okay, so I'm going to add 1 to both sides because I got to get this x by itself, so I need to get rid of any other numbers that don't have any other variables. That leaves me with 2x equals 3 plus 1, which is 4. And now, since I'm multiplying, I am now going to divide, and I'm going to be left with x on this side equals 2. Okay, so we say x equals 2. So 2 times 2 is 4, minus 1 is 3. Check. All right, let's solve this last one. I'm running out of room. I'm going to kind of come, well, maybe over, I don't know. Let's just kind of sneak it in over here to the side. Okay, so 2x minus 1 equals 5. I'm going to add 1 to both sides because that cancels out. I'm left with 2x equals 6. Divide each side by 2. That cancels out. X equals 3. So we think it is 2 times 3 is 6. Minus 1 is 5. Check. Okay. All right. So let's take a look at the next one. It's going to be the exact same thing where we are just going to be working backwards. Actually, let's go to the next page and let's do this right here because I like this problem to where we get to graph it, because graphing is like one of the best parts of this whole thing. Okay. So we've seen how it works with our examples and how we're going to work backwards after we have our output. But now we're going to move to this part right here. Okay, so looking here, Brianna bikes 12 miles per hour. The function rule represents 12x, and x is the number of hours. Make the table to find how many hours she biked in 12, 36, and 48 miles. So we actually know that we want to know how many she has gone in 12 miles, 36 miles, and 48 miles. Okay, so we're going to work backwards, and we know it is 12x. So let's start. 12x equals 12. 12 divided by 12 is, 12 divided by 12 is 1. 12 divided by 12 is 1. Therefore, 1 hour took her 12, because 12 times 1 took her 12 miles. Let's do the next one. 12x equals 36. We're going to divide each side by 12. And x is going to equal, that cancels out, 3. That means 3. So 12 times 3 is 36. Okay. And then our next one is 48. So 12x equals 48. We're going to divide each side by 12. And x equals 4. Because 12 times 4 is 48. Now we get to graph this function. So this is what's awesome. So it says that our x is going to be the hours, because remember our x-axis goes from left to right or horizontal, and our y goes up and down or vertical. So that's our y. So remember, we have to run before we can jump. So we have to run over to 1 and jump up to 12, which is right about there. Okay, and then I'm going to put 1, 12, and then because it is my x and my y, notice x, y. Then I'm going to go over 3 and up to 36, and I'm going to go ahead and put 3, 36, and then I'm going to go over 4 and up to 48, as close as I can. Oh, that was not right. Hang on. I'm having a hard time seeing these. 48 right there. Sorry. So 4 and 48. Okay. So you can see how my line kind of makes this nice little slope. Okay. All right. I'm going to stop here. If you get it, you can go ahead and move on to your homework. If you don't, we're going to look over at the independent practice